This question is the formula of allyl bromide is. So how to write the formula of allyl bromide? So for writing allyl halide, we can write a halogen which is connected to an allyl carbon. So halogen atom is connected to a carbon which is again connected to a double bonded carbon. So this carbon is called a allyl carbon. So halogen atom is connected to a carbon, that is an allyl carbon, that means which is again connected to a double bonded carbon. So instead of X we can write Br, then Br is connected to a carbon which is connected to a double bonded carbon. Now we can fill the valencies of each carbon atom. Now the formula of the compound is CH2 double bond CH single bond CH2 Br. So this is the formula. Now option B is the answer. Option B is the answer. Now let's see the second question, that is which of the following has weakest bond and lowest bond enthalpy? Weakest bond and lowest bond enthalpy. So some alkyl halides are given. So let's see the CX bond in each case. So let's see the CX bond in each case. In the first case it is CF, second case it is CCl, then CBr, then Ci. So these are the bonds or the CX bonds present in these haloalkanes. And we know that the size of the halogen atom, is in the order fluorine less than chlorine less than bromine less than iodine. So this is the size, the order of the size of the halogen atom. And we know that the size of the halogen atom increases, the bond length increases, and bond enthalpy decreases. So in this case, so I is having the more size and Ci bond length is more in this case, and bond enthalpy in this case is less. So the Ci bond length is more and bond enthalpy of Ci is the lowest. So Ci bond can be broken very easily. So in this case CH3I, so that is having lowest bond enthalpy, CH3I. So option D is the answer. Now let's see the third question. The synthesis of alkyl fluoride is best obtained from free radical, Schwarz reaction, Sandmeyer reaction, Finkelstein reaction. So for the preparation of alkyl fluorides, so Schwarz reaction is the best method, that is we can write the preparation Rx plus AgF gives Rf plus AgX. So this is a halogen exchange reaction. So X and F, that means halogen exchange reaction takes place here. So this is a Schwarz reaction, and RF, so alkyl fluorides are prepared in this case. So option B is the answer. Option B. Now let's see the fourth question. Benzene diazonium chloride can be converted into iodobenzene by the reaction with. So benzene diazonium chloride. So benzene diazonium chloride can be written like this, N2Cl, that is benzene diazonium chloride, which is converted to iodobenzene, Here Ki, the reagent Ki can be used. So Ki can be used. So in this case option B is the answer. So the fifth question is, toluene reacts with chlorine in presence of sunlight to give benzyl chloride, orthochlorotoluene, parachlorotoluene, both B and C. So reaction between toluene and chlorine. So this is toluene. So toluene plus chlorine in presence of sunlight. So in presence of sunlight, the reaction is actually a free radical substitution. So substitution reaction takes place here, and one chlorine is substituted in place of one hydrogen. So it will be CH2Cl. That means one hydrogen is replaced by one Cl. So there is substitution. So and HCl will be eliminated. So this is the compound formed, and this is called a benzyl chloride. This is called a benzyl chloride. So option A is the answer. Option A is the answer. Now let's see the sixth question. The conversion of alkyl halide into an alkene by alcoholic KOH is classified as substitution, addition, dehydrohalogenation, dehydration. So alkyl halide into alkene. So alkyl halide, we can write one example, CH3 CH2 Br. So in presence of alcoholic KOH, actually this bromine is attached to this carbon, this is alpha carbon and this is beta carbon. So one hydrogen from beta position and Br from here, and HBr is eliminated. So HBr is eliminated from this compound and we will be getting CH2 double bond CH2. So this is beta elimination. So this is called a beta elimination, or it is called a dehydrohalogenation. Dehydrohalogenation, since one hydrogen and one Br. So hydrogen and Br is eliminated from this. So it is called a dehydrohalogenation. So this is alkyl halide is converted to an alkene in presence of alcoholic KOH. So the answer is dehydrohalogenation. So option C is the answer. Option C is the answer. Now let's see the 7th question, that is racemization occurs in SN1, SN2, neither A and B, both A and B. So racemization, actually racemization occurs in SN1 reaction, and inversion of configuration occurs in SN2 reaction. So SN1 reaction proceeds through racemization and SN2 reaction proceeds through inversion of configuration. So here SN1 is the answer. So option A is the correct answer. Option A is the correct answer for question number 7. Now let's see the 8th question. Which of the following is most reactive towards nucleophilic substitution reaction? Chlorobenzene, 2-nitrochlorobenzene, 2,4-dinitrochlorobenzene, 2,4,6-trinitrochlorobenzene. So which is the most reactive compound towards nucleophilic substitution? So let's see the compounds. The compounds are chlorobenzene and derivatives of chlorobenzene. First one is chlorobenzene, second one is 2-nitrochlorobenzene, and third one is 2,4-dinitrochlorobenzene, and fourth one is 2,4,6-trinitrochlorobenzene. So in this case we can see an NO2 group. So NO2 groups are here. So in the fourth case, in the last case, there are 3 NO2 groups. So NO2 group is an electron withdrawing group. So electron withdrawing groups are here. So number of electron withdrawing groups increases, which stabilizes the intermediate carbocation. So the reactivity will be more. So in the last case, that means there are 3 NO2 groups. So electron withdrawing groups are more in the last case. So the reactivity will be more in this case. So option D is the answer. Option D is the answer. Now let's see the 9th question. That is, which of the following will be hydrolyzed most rapidly under similar reaction conditions? 1-chloropropane, 1-chlorobutane, 2-chloro-2-methylpropane, 2-chlorobutane. So for 9th question, we need to check the type of carbocation formation in the compounds. So 1-chloropropane, that is, this is 1-chloropropane, the skeletal structure, and second one is 1-chlorobutane. So this is 1-chlorobutane. Then 2-chloro-2-methylpropane. So 2-chloro-2-methylpropane. Then 2-chlorobutane. So 2-chlorobutane. So let's see the type of carbon atoms, or the chlorine is attached to this carbon which is directly connected to one carbon. So this is primary, and this carbon is connected to only one carbon. This is again primary, and this chlorine is attached to this carbon which is directly connected to 2 other carbons. So this is secondary. No, it's there are 3 carbon atoms. So this chlorine is attached to this carbon which is directly connected to 3 carbon atoms. So this is tertiary actually. And in the fourth case, it is this carbon is secondary, that is, this carbon is connected to 2 carbon atoms. So chlorine is attached to this carbon which is directly connected to 2 carbon atoms, so it is secondary. So this is the tertiary, and we know that tertiary carbocation is more stable. Tertiary carbocation is more stable, and this compound forms a tertiary carbocation intermediate. So tertiary greater than secondary greater than primary. So this is the order. So tertiary carbocation is formed in the third case. So option C will be the answer. Option C will be the answer. Now let's see the 10th question. Which of the following is used as an antiseptic? Which of the following is used as an antiseptic? CHCl3, CHBr3, CHI3, CHF3. And we know that CHI3 is called a iodoform, which can be used as an antiseptic. So option C is the answer. Now let's see 11th question. Freon leads to depletion of O2, O3, NO, NO2. So it is ozone. So it is ozone. It is O3. So option B is the answer. Then 12th question. Inversion of configuration occurs in SN1, SN2, neither A and B or both A and B. So inversion of configuration occurs in SN2. We have already seen that is SN1 reaction proceeds through racemization, and SN2 reaction proceeds through inversion of configuration. So SN2 reaction proceeds through inversion of configuration. So option B is the answer. Option B is the answer.